Hello and welcome to the Learn Clang Screencast that is all about rock, paper, scissors. In this episode, episode 7, we will basically just improve the our class hierarchy, because last time we've just converted the C program into C++ as cheaply as possible, as quickly as possible. And today we will make it a nicer C++ program to be a bit more, well, how to say that, C++y. Therefore, we build a class hierarchy and use polymorphism based on that. Polymorphism basically means that through a certain kind of object, that usually is a base object, you get different kinds of behavior, just because underneath of that pointer or object, there is actually hiding another type of object. Did I explain that correctly? Probably not, but we will see if we get a clearer understanding of this while digging into the code. Qt creator. Okay. By the way, the format changed a bit. The format of the series changed a bit, as I think I won't stream this anymore. Instead, I will do high quality recordings and try to keep the episodes short and snappy. So there's just one thing we do per episode, and that is it. So a better focus, maybe. Okay. So currently we just have an, wait a moment. I think I'm in the wrong project here. Yes, that's the C project. Oh my God. Of course we have to open up the CPP project. I apologize. Same thing, but different. Same, but different. And I shall also close this one. Not to confuse the different main.c files that I have here. Okay, that's definitely good enough. And the rest should be as expected. Now main CPP. Now I should have known that when seeing main C that I'm seeing a C program here. So let's have a look at rps.hpp just to see what kind of data structures we have built so far. RPS item, that shall be our new base class. And it's okay to keep it a struct so that everything is publicly accessible by default. It's fine, I don't mind, because we will usually hand out constant versions of that thing anyway. But what I would like to do is to kind of get the special knowledge that rps.cpp has into individual types. I'm saying that I would like to have an RPS item that is a rock, that is paper, that is scissors. And because we have a little taxonomy going on here that is based on hierarchy, we can say that a rock is an RPS item, a paper is an RPS item, scissors are an RPS item. That's what we are going to build now. So first things first, let's declare our types. Should we make it structs to make everything public? Why not? Oh, you know what? Oh no, let's do one thing at a time. Let's make structs here. We will make it classes later, I think, and then learn about access permissions. Right now, right now a struct is just fine. So let's have a rock, which is derived from RPS item. And I don't know what the default derivation is if you're talking about structs. Should be public, but I don't know that actually. I'm saying that this is the syntax for deriving from a class, right? So this rock is now an RPS item, but you can have access specifiers for this as well. So you would usually say, I want to publicly derive from this. This keeps everything as open as it was here in the RPS item, because the default derivation is private, which kind of totally hides all functionality and members of my base class. This is something I don't want, even though it could be that if you are dealing with structs that the default is indeed public, but I don't know that, to be honest. I usually use classes and then you specify it. Probably not a bad thing to specify it. Pubic, no way. So I will just try it out, Sometimes I'm thinking, okay, you could study the manual, but you can also just try it, which will be faster and kind of sticks better in my head than reading paper. reading letters from screens. All right, so what I would like to do is, well, yeah, I've got great ideas for the next episode already, where we probably will do access permissions in classes and structs. But I would like to do is that this thing initializes itself, so a rock should know its name, a rock should know its ID. This is something you implement in the constructor. So right now we are just declaring the constructor. We will not implement it here because that's a header, you know. Header contains declarations. And the compile units, the CPP files, they contain the definitions. Okay, let's just, well, I could copy this, but I can also write it down. Let's just create our types here real quick. That's a bit of a grunt work. Again, there is no real way around that unless you have code generators, which probably we will never have for this program, but who knows. And then there is scissors. Oops. Like so. It knows what I want because that's just the default name for the, or that's just the default constructor. By the way, again, a constructor without, I have to correct myself, parameters is the default constructor. You know, or let's rephrase it even more. A constructor without you needing to set any parameters is the default constructor. Yeah, we might get to the details of this later and why I kind of rephrased myself, but that's just it for now. So now let's define these things. I'll just be lazy here and fast and say add definition, please. And now it's great that we see that here. Our base class RPS item has an awesome constructor which allows us to initialize the name and the ID accordingly. And that's something we just want to call now in our own initialization. And also what I want to do is I would like to remove this function pointer because we don't need it, and instead define it as something that others have to implement. How do we do it? So now it's not a function pointer anymore, but it's a function. We declare it as Virtua and set it 0. Wow, so that's a pure Virtua function. That's so many new things, pure and Virtua. And it's actually not a function, but it's a method, right? Because it's part of the object. Awesome. So what does it mean? Virtua means that in case this RPS item, or in case you have a pointer to an RPS item, but that RPS item is actually a rock, call the method on the rock instead of on RPS item if rock defines its own method implementation, right? So this is a polymorphism right away, Virtua. If you want to have a hierarchy-based polymorphism in C++, then make your methods Virtua. Setting them 0 is kind of a fancy way to kind of set a null pointer here, which kind of makes sense. Pure Virtua functions, they basically say that this base class does not implement this method here because it makes no sense for an RPS item. You know, an RPS item kind of is nothing really, and it doesn't know what a rock would say if you have lost. You know, it doesn't know that. It can't know that. So that's basically what we say. This also means that you cannot instantiate an RPS item itself because it has methods which you cannot call. You know, an RPS item is now basically just a base class and never more. You need to derive from it to ever be able to use an RPS item in any way. That said, now we can, we not only can, but we have to say, implement this here. We just declare it. Again, oh, sorry, it's the wrong signature. We just declare it here and define it somewhere else. We also say it's still Virtua, even though that's something that is implied, so the compiler wouldn't bother. By the way, if we would not declare that here, we wouldn't be able to instantiate subclass, because I mean the compiler wouldn't even compile that, because, well, I think it would compile it, but only if you don't try to instantiate the subclass. Anyway, long story short, now you have to implement this function as this method. You do have to do that. Otherwise you can't use this subclass at all. But we want to use it, right? So let's copy the declarations here. They're all the same. And now we have to implement this one after another. Back to the RPS item. I did that just to get rid of this additional function pointer that I passed, because now we have a real virtual method to do that. Yes, please refactor my change. And there we go. And now we shall go back to the implementation here of my rock, and also to this one here, and to this one. Let's just fix it up real quick. We have to fix more to make this work, obviously, but you know, let's just see how far we can get with just our brains working and let the compiler do the rest for us. So now I'm going to use the initializer of my constructor once again, but this time I'm calling my own base like that. And you can see I can just name the constructor of my base that I want to initialize and then pick one. So I want to use this specific one, which says the name is rock and ID is 0. It is, right? Yes, yes, yes. Okay, the rest I should be able to memorize here because it's simple enough, even for me. So let's go back and let's just add all these definitions here. Let's do one after another. That's kind of the grunt work again. I will try to do this real quick. And say you lost. Here you go. I will just copy this. So here we have the implementation of our individual C functions, but I'm copying this implementation now. I don't have hotkeys to jump pages up and down. I don't have this keyboard key. So that's already the rock implementation here. File, I should probably name it stream. And that's a change I don't have to do, you know. If you, in the declaration, you don't necessarily have to name your parameters. It's enough to just have the type, you know. But if you want to use this parameter, obviously you have to assign it a symbol, a name, in other words. All right, so let's go back to, to the header. How do I do this? F4. And let's do the paper. Grunt work, boring. I know, I'm sorry for this. So here we do some heavy copy pastes. I should be able to manage this because paper and 1. And then we have paper papers say you lost, which is that one. Papers, they feel divided. Okay, and the last one shall be scissors. Let's do the constructor. Okay, copy paste with adjustments. I'm not a fan of copy paste, honestly, because you always put in some subtle bugs, you forget stuff. You know, because this one is kind of easy to handle because things that I have to change are so close to each other. I trust myself to be able to do it. Otherwise, I don't really trust myself. And you know, even though other people might trust themselves more in that regard, you will put in bugs if you copy paste. Just a question of how many and when it will happen, but you will. And then you will be looking for that bug forever. Or let's just say for a longer time than you know, it would have taken you if you would have just typed that stuff in the old-fashioned way. Just saying, just speaking out of experience, maybe that's just me. But copy-paste is a possible hazard. So the scissors feel crushed. Oh yeah, see, copy-paste. No wait, that was just refactoring going on. So that is missing stream. Now we should be fine on that side. Awesome. So let's look at these RPS items. I can tell you that they don't work anymore because we can't instantiate an RPS item. We don't have these functions anymore. All this changed. good for, I mean, also something we cannot do is that, because this is of type rock now, but we can only store RPS items here. And because rock could have its own memory layout, its own members, its own thing, you cannot assign this to this RPS item type array. It doesn't work. It's not Python here, where you can mix and match everything and see everything is kind of statically assigned, and you have to know what you're having here. And therefore that doesn't work. But what I can do is I can store pointers to items and then just assign these pointers instead. But to assign a pointer, I first need an item, right? So what I'm going to do is to try to locate these we just have these 3 items here, rock, paper, scissors. So I can just try to locate them statically here and keep their memory basically in my compile unit. And that's the only place where these guys will live in. So let's have a rock. And let's have paper. And let's have scissors. So as you can see, the naming conventions is obvious. If you have a type, then it starts with a capital letter and it's camel case. If you have a symbol, they always start with the lowercase letter. And because I like it, I use underscores. That really depends on the library you're seeing. Some use camel casing and some don't. It's, conventions, and you set them up yourself. Good, now that I have these pointers here, I can now just assign the address of my rock instance here to the first slot. And now I do the address of the paper here to my second slot, and the address of scissors to my third slot. And there we go. So that is now a valid array. And as you can see, C++ is smart enough to realize, oh, a rock is an RPS item, right? So we just store the RPS, we just keep the pointer to our underlying RPS item. But this C++ still knows that in fact this is a rock. That's the cool thing about C++, it keeps track of that. In C, you have to keep track of that yourself. In C++, C++ has means to allow you to dynamically determine the type of something, and it's called runtime type identification system, which you can also deactivate in case you don't want it. But this kind of stuff will always work, even though, long story short, this will always work, it's fine. That's the way you would do this, rest stays the same. Now we have to adjust these things here, possibly, or at least review them. That shall still be fine. Oh, yes. Well, I found a bug just by thinking about it, but we will just run into this then. So that looks good to me, RPS item by name. That doesn't look good to me anymore, because now we kind of have them statically located. We can't just mem copy this safely anymore, because now we have derived types in there. And as I said, the memory requirements for the derived types could be different to the memory requirements of a base item here. So that's not going to work anymore. Even though in our case it is going to work, it's a very hacky thing that you would never do in C++. Unless you really know why you want to do this, and if you want to do that kind of stuff, you probably don't want to use C++ at all. You want to use C instead, which is fine, but you shouldn't do that. So let's just say we go back. We had different versions of this, right? We used the heap ones, and then we said, yeah, well, the caller should allocate memory for us, and we just put the stuff there, and then return a valid pointer to the destination if that worked. And now we say, you know what? We will return our static item pointers that we have initialized here, and we shall be fine. There was a version that we had before as well, which is kind of, that's a version I would endorse also. If you have to go all overboard with the object-oriented stuff here, if you want that, then let's keep it real. Keep it real. Can I say that without being silly? I'm just saying, let's not go overboard with everything else. We try to approach kind of a relatively decent design, under the requirement that we have to use an object-oriented design, which can be disputed in this simple program, obviously. So let's have a look at this. Now we traverse pointers to pointers. So it's more like that. All right. And now we have to dereference that guy twice. And that doesn't work by kind of doing this. No, but now we first dereference our iterator that gives us a pointer to an RPS item. And then we can just use the dereference short name here or shortcut syntactic sugar to do that. What we could also do is that, voila, a double dereference. Just jump to the first pointer, then jump along that pointer to the next pointer. Yeah, because it has less characters, I kind of prefer that way. I don't know what's more confusing or what's not confusing. I think that's clearer that I'm doing a double dereference here without having that kind of syntactic sugar dereference going on. All right, destination doesn't exist anymore. I just want to return a pointer to my RPS item, which means I have to dereference this guy once. All right. That is good now. The rest, I think, didn't change. Now we have to check the main CPP just to see how he's using that. Okay, RPS items. We don't need our own storage anymore. We just get static storage returned. Then we get a pointer to a result. Okay. If that isn't a valid pointer, we are unhappy and will complain. Same here. Oh yeah, sorry. Now I have to actually keep these guys around. RPS item pointer P1, P2. So P1 is that. If it's not a valid one, skip that one. Same here. P2. And then we do the matching. So previously we had the item itself on the stack. Now we have pointers. So previously we had to take the address of the item on our stack, but now we don't have to do that because we already have pointers here. So let's just remove this. Fine. And now the interesting part. Here we call our functions. Methods, sorry. I don't know why I'm always getting this wrong. It's not the same, right? So here we call our methods, and previously we had to dereference our function pointer and then make the call. But now this looks much more convenient because now, why doesn't it know that? Didn't it update it? It kind of didn't update its, how to say that, its code model. So it still thinks this is not a pointer. It still thinks this is an object that is on the stack, which is just not the case, man. It's not true. Or I'm seeing it incorrectly. Can you please update yourself? How do I make it update? It still thinks the wrong things. Update code model. Come on. This was here, C++. Open declarations. No. I remember that I was looking for this before. Maybe they have removed it because they thought that this is not necessary anymore. But I think it is. I do think it's still not right. Well, anyway, I just have to live with that. Maybe I'm wrong. Maybe I'm totally wrong and the compiler is right. Code analyzer is right, but yeah. I take that bet. I'd say I'm right. Now it's got it. Fine. Awesome. Well, took it a while, but you know, better late than never. And that's it. And you know, still remember that P1, P2, that's RPS items. And I'm calling this virtual method now that will kind of automatically invoke the implementation on our derived class, which is or our derived type, which is still underneath that pointer, right? And that's the cool thing. You can work with stuff you know, but you know that in fact underneath there is your own custom implementation of a certain interface. You know, we have defined an interface that says RPS items, they can say that you lost and they have these constant members here, and let's make this a constant as well. And things like that, you know? Okay, long story short, let's compile this. Variable type RPS item is an abstract class, okay. Interesting, see? This is why it thinks P2, so I was wrong after all. Look, if it's a pointer, this doesn't work because apparently for him, maybe I have to do it like this to say, hey, come on, it's still an RPS item, but make it a pointer, please. Okay. Interesting. Oh yeah, true. We have to return a constant RPS item because here we have constant RPS items in store, right? We don't want this to change ever. That's true. And here we return a non-constant one, which is stripping off or basically adding permissions. You know, now we kind of try to add write permissions to something that doesn't have write permissions. Constant RPS items all over the place. And that's the problem here. So we have to say that this is constant. In the definition, let it refactor our declaration. This is so convenient that it can do that. Otherwise, we would have to jump back and forth between header and implementation and change it twice. And now, yeah, we can compile again. Assign into RPS item. Oh yeah. So look, here again, my bad. Of course, it's a constant RPS item. And last thing, member function. Say you lost, not viable. This, I mean, I knew that this would happen, by the way, but I wanted to see it so that we can talk about it. Member function, can I increase the size here? Increase size, increase size? I think I can do that somehow, but anyway. Member function, say you lost, not viable. This argument has type const RPS item, but function is not marked const. That's actually a very nice compiler message, honestly. Back in the days, like 10 years ago, I think they have been a bit more difficult to understand, at least to me 10 years ago, but 10 years ago I was, yeah, I had no idea, right? Even less than now, I say. Okay. So here I tried to call this, and here I declare it. So what's the problem? The problem is that every method that is not declared constant, like so, is allowed to change the underlying object. And this change of an underlying object can only occur if your object is not constant. But my RPS items, they're constant all the time because I want that. I don't want this stuff to change ever. You know, I even say, okay, I'm pointing to an unchangeable character string, and the pointer that points to it should also be unchangeable. You know, this stuff is as constant as it can be. But this method would have had the ability to change the underlying object, which is invalid on a constant pointer, you know, on a constant object. So now I defined it constant, which says this method here is not going to change the underlying object, which is vital. And I'm saying you should always, you must always declare your methods constant if they are just, you know, like returning a value, like value getters. They're always constant because they just return a value for the most part. There are special ways to circumvent this while still declaring it constant, but we might talk about that later. I'm just typing this here for a second and leave this uncommented so that you can possibly scratch your head about what that means, but let's keep it simple for now. So now that this is constant, I have to adjust all the declarations here. Adjust declarations, adjust declarations. And look how much overhead we have now through all the declarations and definitions just to get this polymorphism going. I mean, is that worth it? Does it make the program easier to understand? More maintainable? Faster? Better? Fancier? No. Fancier? Yes, kind of, but better? No, definitely not. The first C program I wrote here was, that was the one. That was the nicest solution to the rock, paper, scissors game. So that's just more difficult, and that's, it's interesting. Choose the right tool for the job, and I'd say C is the better tool for the job than C++ in this case. At least if C++ kind of makes you go object-oriented all the time. C++ you can obviously implement just a C-style program, but yeah. It was an interesting lesson for me too. Okay, so now I've made all this stuff constant. So it should work now, but I will not recompile before we talk about this thing here. This, not viable. This argument has type const RPS item. This argument? Where is this? What is this? I could say, what is this argument? I don't see a this argument. Do you see it anywhere? I don't see it. It's not there. It's just not there, which is truly the case. But whenever you are in a method of a certain class, you have an implicit this argument. It's like the self in Python, which is an explicit this argument or an explicit self argument. In C++, this is implicit, and it's a pointer. It's a pointer to yourself. So in case you want to kind of very explicitly access or want to have a pointer to yourself for whichever reason, you have it in the this pointer. So you can do this and then access your own members. For instance, you could print your own ID here if you like, or whatever. The cool thing is that because it's all implicit, if you want to access your ID, you can just do it like this, and the compiler will know, oh, you probably mean your own ID. Obviously I didn't define an integer ID here, but I can, I can have an ID here that is an ID in my local scope of the method. And now if I want to access my own ID, I have to do it like that, because now it's ambiguous which ID I mean. It's still not ambiguous, so I can still do this. Can I? I think I should be able to, but maybe I'm not. Let's try. Oh, that works. Even though he can't do it anymore, it's just the syntax highlighting that kind of fails on this, even though it's not fading, because it knows, you're declaring a new ID symbol here, and you want to assign it ID. Well, considering that this thing is not yet declared or defined, until it's defined, this ID must name your own ID. That's exactly the same. Okay, it's unused, sure, but you know what I mean. And that's this. That's the this pointer points to yourself. It's like self in Python. Awesome. So I can just run this. It works as before. Nothing changed, but our design changed quite a bit. I hope you liked it, and I guess I see you next time when we deal with access permissions in structs and classes and stuff like that. Have a good day, and thanks for watching.